Today we're talking about how do you program the color sensor on the ADPS-9960 sensor. I'm Brogan Pratt and I've been teaching robotics to students for over 10 years now. So hopefully this tutorial can help you out getting yourself up and running with this little guy. So wiring up one of these sensors is quite simple. You could directly solder wires onto these pads here. You could use a male pinout that you could push into a breadboard. And then you could solder this directly on, or even just rest it on top. That would be fine too. And then the last option, which is what I'm going to use for this tutorial, is using a little 4-pin JST connector. So on your board here, with the proximity sensor facing up, you're going to connect to the left-hand side. The right-hand side allows you just to tag off and daisy chain to other I2C connectors. We're going to go ahead and connect black to our ground port, red to our 3.3 volt port. Yellow is your clock, which should go to SCL. And then blue is your data, which is going to go to SDA. That's it. Super simple to wire one of these up. Let's go get programming. We're going to start by importing a few libraries. I'm going to import board as always, import time, import bus IO. And we're also going to import Adafruit _APDS-9960 dot APDS-9960. Oops, not improt, import. You're going to need this library added to the lib folder on your CircuitPy device. And on your CircuitPy device, underneath your lib folder, you're going to have to make sure that you have the Adafruit _APDS-9960. I'm going to add that library down below if you need that. Then we need to initialize the I2C port on our board. In my case, the I2C port is equal to busio.I2C and board.scl and board.sda. I'll go ahead and close that bracket off. Then we need to actually create our sensor. So I'm going to go ahead and call this one, I'll just call it sensor. It's equal to Adafruit APDS-9960 dot APDS-9960 dot capital APDS-9960 open parentheses with our I2C port. And that's it. That's our first initialization done. Now to program this as a color sensor, you have to go ahead and flag that color sensor as true. So I'm going to say sensor.enable_color, American spelling, equals true. And then I'm going to add a while true loop. And we're going to say R, G, B, C is equal to sensor.color_data. So we're going to assign 4 different variables to the 4 values that the sensor.color_data will give us back. Then we're simply going to go ahead and print this. So I'm going to say print red, comma R, green, comma G, blue, comma B, and clear, comma C. I'm going to add a tiny sleep in here to allow us to have a little bit of delay so that we can actually see what our color readings are. So let's go ahead and save this. Let's go over to C report. So this is going to turn a value between 0 and 6,000 or 65,535. So if we were to take a red object and move it close to the sensor, you'll notice that our red object starts getting far higher values. If we were to take a green object and move it closer to that color sensor, you notice that now our green is starting to get higher values. And if we move a blue object closer, you'll notice that our blue object is starting to give higher values. It's going to be better if you have higher saturations or light off of these as well. So let's actually wire up some of these LEDs quick. So as I bring my color sensor closer to a blue light, you notice that our blue starts to peak a lot higher than the other values. If I were to swap this out for a red light, you'll now notice that our red value starts to peak a lot higher than the other values. Swap it out for a green. And now our green value is kicking out a lot higher than the other values. Now, because a value between 0 and 65,535 is not super useful, we can go ahead and use a bit of a map range. And I'm going to use a helper function to do that. I'm going to say from Adafruit underscore simple math import map underscore range. And what map range allows us to do is allows us to take a low value and then a high value and turn them into a new range. So we could say between 0 and 65,535, we can turn between range 0 and 100. So let's do that. So I'm going to take all of my data here and I'm going to go ahead and I'm going to sanitize that. So I'm going to say R is now equal to map underscore range. R is the value we're going to change. The current low value is 0. The current high value is 6,535. I'm going to change it to a new low of 0 and a new high of 100. I'm going to go ahead and do this for the rest of my other 4 variables. I'm going to do red, green, blue, and clear. I'm going to make sure I do it over here. Red, green, blue, and clear. And if I save it over, now you notice that our outputs are between 0 and 100 as opposed to 0 and 3,605. If I don't want to have a float here, I could also do something like round and do that. And now I've got nice rounded values. So if I were to push up to my green sensor, I'm getting much higher on my green values. And that's it. That's how you use a color sensor. So best of luck on your robotics project.